Hey everyone, Mr. Catnaps here. I haven't done one of these videos before, so please bear with me. Here's a quick DIY on how I control my LEDs when powering up a gaming console. Skip to the end of the video for a demonstration, but for now, we're going to jump right into it. The requirements are an adjustable LED string. I'm currently using an Olitub brand, an ESP8266 microcomputer. These come in a variety of shapes and sizes, but I'm using a Node MCU because we're just prototyping, and a micro USB cord. I'll link the three things that I'm using in the description below. For the tools you need, a soldering iron with a thin point, solder. I normally use a 60x40 resin core, and some 20 gauge wire. I have twin 20 gauge wire, but we need 3 strands. So I measure out 2 pieces of the twin wire and split one of them. I kept the ground and the GPIO wires connected and used the loose wire for a 5-volt connection. You don't want to cross any of these wires because you might blow your light strip, or in my experience, your Node MCUs. A tip on soldering to LED pads, and I'm sorry for the low quality video. Heat the pad with the tip of the soldering iron, then add enough solder that it covers the entire pad. Lay the exposed wire on top of the soldered pad and push the wire into the pad while heating. Make sure the solder fully covers the wire and you'll have a solid connection. This will make sure the wire is secure against the pad and they don't overlap. Now that you are connected to the strip, we need to solder the other end to the Node MCU. Connect the 5-volt pad wire to the VIN on the Node MCU, and this will provide 5 volts to the light strip. Next, connect the data pad wire to the GPIO pin on a Node MCU, and I generally use the onboard labeled D8 pin, which is the same as GPIO 15. Finally, connect the ground pad to any of the ground pins on the Node MCU, and you should be fully wired up and ready for the code. The code will be linked in the description below, but let me quickly run through the 3 most important aspects of it. First, LED scenes. This is where LED scenes can be set for the LED strip. We are currently using fade, but there are 8 other options plus solid colors. Second, AWS MQTT sending messages. This is for sending the console color to the living room lights. And third, AWS MQTT receiving messages, which is used to change the LED scenes. Now, how it works. On a power cycle from the console, the ESP8266 connects to my Wi-Fi, sets the cabinet light to a specific color for each gaming console, then sends that gaming console's color over AWS MQTT to my living room's ESP8266, which will change the living room's LED colors. Then each console will fade random colors every 10 seconds. When mounting, I was lucky to have a 3-inch lip on my media station, making it possible to use a crude tape job without being an eyesore for the rest of the room. I connected the USBs of each console up to the ESP8266s, and they should start on power up. Now let's pull this camera to the back of the room, turn on the PS4, watch its box turn red, the room turn red, then we'll power up the Nintendo Switch, watch its box turn aqua, then the room turn aqua, and finally each box individually fading random colors. While building this, I did run into a couple of issues, the main one being the Switch doesn't have a dedicated mode that turns off USBs. This means I have to use an external program to turn off the console box's LEDs for the Nintendo Switch. However, there is a power cycle, whether it's in sleep mode or off, so I can tell when the Switch has been turned back on. Alright, that's it for this video. I'm just going to play some random scenes now. I hope you enjoy them. If you like what you saw, if you learned anything, like and subscribe, and I'll be back with some more videos in the future. Thanks everyone.